right, hello and welcome to Algebra Honors. This is Unit 8, Quadratics, Day 1. We're talking about the graphs of a quadratic function. And so this is our second video, and we've done some examples where we talked about parabolas opening up, parabolas opening down, and we have talked about x-intercepts, which can be called roots or zeros or solutions. And we've talked about the vertex, which is the absolute minimum or the absolute maximum, depending on the direction of your parabola. And we've talked about the y-intercept. Okay, we've also talked about domain, which is all of the possible x values of our function, and range, all the possible y values. So here we are, we're going to look at this equation. Okay, and I know that in this case, a equals -1, b equals -2, and c equals 3. So I can see that my a is negative. If a is negative, then that graph is going to open downward, and sure enough it does. Okay. So I'm going to kind of go back and forth between these two boxes. If I factor this, remember our first job as mathematicians is to pull out any greatest common factor. We're going to pull out a -1. And then we're left with x squared plus 2x minus 3. Okay. So if I'm factoring that, I want to find two numbers that multiply to give me 1 times -3, so -3, but they're going to add together to give me 2. So I'm going to say that that must be 3 and -1. 3 times -1 is -3. 3 minus 1 is 2. So those are my magic numbers. And because my leading coefficient right now of the trinomial in the parentheses, the leading coefficient is just 1, I know that I can rewrite this as -1 times x plus 3 times x minus 1. I used my magic numbers. Okay, in our last video I told you, sneak preview, these factors, these binomial factors, give us a hint about our x-intercepts. So there's something to do with 3 and something to do with -1, right? We're not going to go into super detail, but look, I do have an x-intercept at -3, 0, and I do have an intercept at +1, 0, so I do have the 3 and the 1 in there. Just keep that in the back of your mind, okay? So here, my axis of symmetry, remember it's going to be the x value of my vertex. So I can either look at my graph here and I can see that that vertex is at -1, 4. Okay, so if I can clearly see on my graph, I know that the x value is -1, right? I know this is going to have to say x equals -1. But let's just make sure, okay? Mathematically is usually safer. So let's plug in what we know. X equals -b. Well, b is -2, so I want the negative of -2 over 2 times a. A is -1. I did my a, b, and c from the original function, the original equation. That's what you should definitely do, okay? Not from my factored stuff. All right, so my x value is negative of -2, that's +2, over 2 times -1, that's -2. And so when I do this mathematically, I also get x equals -1. All right, so x equals -1 is a vertical line at x equals -1, right? And to find the actual vertex, if I couldn't see it on that graph, I'm going to find it by plugging in what is -b over 2a. What is the x value? -b over 2a is -1. So I'm going to find the f of -1, right? Because this is -1. The f of -1 means use this function, and any place you see an x, you're going to put in -1. So let's be careful and let's use parentheses because we've got negative numbers. I want the negative of -1 squared minus 2 times -1 plus 3. I know my x value is -1, so I'm plugging in -1 any place I see x. All right, -1 squared is +1, and the negative of +1 is -1. -1, -2 times -1 is +2, so -1 plus 2 plus 3. I have -1 plus 2 is 1, and 1 plus 3 is 4, okay? I can see that the f of -1, when x is -1, the function value is 4. That's my y value, or my f of x. And does that match up with my graph? It sure does, and that's good, right? So we have a couple different ways to solve some of these problems, but a lot of times we're going to come straight from an equation. I just want you to see what it looks like on the graph. All right, in this case, my parabola is opening downward, so my vertex is the highest point of the whole function, right? So that's an absolute maximum. My x-intercepts happen here and here. I can see that one is going to be at -3, 0, and the other is going to be at 1, 0. -3, 0, 1, 0. Those are my x-intercepts. That means that my solutions are -3 and 1. My roots are -3 and 1. And my zeros are going to be at -3 and 1 because the whole function, the whole y value equals 0 at those points. Right, my y-intercept, there should only be one. I can see that it's at -1, 4, and we've calculated that. So -1, 4. My domain, I imagine all of the possible x's. I can plug in any x I want, right? -4 bazillion. I can plug it in and I'm going to get some y value. It's going to be way down low, yeah? Okay, so domain is all real numbers. Or we can say that we are inhibited by nothing, limited by nothing. We can go from -infinity all the way to +infinity. So we say that with interval notation, -infinity to +infinity. Okay, my range is all of the y values that I could possibly have. Well, I have a stop right here, the highest y value I can possibly have. So I'm going to say my range is y such that y has to be less than or equal to 4. Any y value I get when I plug in some x is going to be at most 4, and it might be something smaller, okay? So you can say y such that y is less than or equal to 4, and you can also say that our smallest y possibility is -infinity, because we really are going all the way down here to -infinity, right? But our highest y value is 4. So we're going to go all the way up to 4, and that's a square bracket because we have a solid circle there. Okay, graph 4. Graph 4, here's my standard form, -4x squared plus 4x minus 3. I know that a equals -4, b, oops, make sure you can see that negative, b equals +4, and c equals -3. Okay? Let's factor it. We're going to pull out a -1 first, and that leaves us with 4x squared minus 4x plus 3. Okay, I'm going to use my x puzzle and try to find factors in there. So I need two numbers that multiply to give me 12, right, because 4 times 3 is 12, but they have to add up to be -4. And I can't really come up with any, so really that trinomial itself is prime. So I'm going to leave it like that. Okay, -1 times 4x squared minus 4x plus 3. Okay, so remember previously when we had two binomials that were in that factored form, we had 2 intercepts. When we had one single unique binomial, we had 1 intercept. How many binomials do we have as factors? 0. How many times do we cross the x-axis? 0. Okay, so let's take a look. Okay, we know that our a value is negative. That's really a -4, and so it's negative, and the graph is opening downward. My axis of symmetry, I'm going to look at my vertex, or I can plug in the information I have. Okay, x equals -b over 2a, so x equals negative, well, b is 4, so -4 over 2a. A is -4, even though I was a little messy, a is -4. I'm going to rewrite that. A equals -4, just so you can see. My gloppy pen. -4 over 2 times -4, so that's going to be -4 over -8, which is +1/2. My x value, x equals 1/2. Okay, that means that my vertical axis of symmetry should be at the line x equals 1/2. And check it out. My vertex is right here at x equals 1/2. Okay, and the person who printed this graph for us was nice to give us the 1/2 mark so that we can see that that is exactly where it is. Okay, once I know my x value, I know that I can find my y value, right? So x is 1/2, so I'm going to say x is 1/2, -b over 2a is 1/2, so I want the f of 1/2. And mathematically, I can plug that in. I'm going to go to the original equation. And so I show that any place I have an x, I'm going to put in 1/2. So I have negative 4 times 1/2 squared plus 4 times 1/2 minus 3. Just plugged in my x value. This is negative 4 times 1/4, right? Because 1/2 times 1/2 is 1/4. Plus 4 times 1/2, that's 2, minus 3. Negative 4 times 1/4 is negative 1. I have negative 1 plus 2 minus 3. Negative 1 plus 2 is 1. 1 minus 3 is negative 2. That's my answer. When I plug in x is 1/2, my y is negative 2. X is 1/2, y is negative 2. Gosh, I feel like I'm getting very, very crowded on my paper. X is 1/2, y is negative 2. Do I believe it? 1/2, negative 2. That is my vertex. 1/2, negative 2. Okay, so hopefully by now you believe me that we can find the vertex by looking at the graph, or we can find the vertex by calculating it. This is opening downward, therefore my vertex is the highest point I could possibly have, so it is a maximum. Okay, my x-intercepts, where I cross the x-axis or touch the x-axis, well, they don't exist, right? So I can say none, or I can say non-applicable. Okay, it's not there. It doesn't cross the x-axis. The y-intercept, though, I can see it. It's right here at 0, negative 3. Or if I know my x is 0, because it has to be for the y-intercept, I could plug it in. 0 plus 0 minus 3, it's going to be negative 3. My domain, I'm thinking of all of the possible x's. Well, we go all the way to negative infinity and all the way to positive infinity from the left and the right. So domain is going to be negative infinity all the way to positive infinity. Any number that I choose in between those two values is going to be something I could plug in. Okay, we can also say that x can be any of all real numbers. My range, though, I do have a barrier, right? There's a maximum, we already know it, there's a maximum range that I can have. So y, any y is going to be y such that y has to be less than or equal to negative 2, okay? Because I'm talking about the whole set of numbers, all of the numbers less than or equal to negative 2, I use those curly brackets. If I want to use my interval notation, the smallest y is negative infinity because we never reach it. But the biggest y is negative 2. This is a closed circle, and so I'm going to use a square bracket. All right, so looking ahead, just you can be thinking about this, and I probably snuck some ideas in. What connections can you make between the factored form and the actual graph? Okay, this is my factored form here, negative 1 times a trinomial. This is my factored form here, negative 1 times a binomial times a binomial. Factored form, can you see my pen yet? Yeah, factored form there. 1 unique binomial, 1. Factored form, 2 different binomials, 1, 1. So your factored form is going to give you some information about your x-intercepts. Okay, so very much. So let's take a look. Graphing quadratic functions given standard form. Okay, now I promised that we can use Desmos for a lot of these, but we can also do this the hard way mathematically, and so you might want to pull out a calculator for some of this. Find the equation of the axis of symmetry. Remember, Vux is your vertical line, right? It's a vertical line where the slope is undefined and x equals some number. And just, we're not using it right now, but hoi would be the horizontal line where the slope is 0 and y. Oh, you can't even read those, I'm sorry. Vux is a vertical line, undefined slope, x equals some number. Hoi is the horizontal line where your slope is 0 value and y equals some number is how you would write that line. Okay, so this is a line, and we can figure out what our number is. The axis of symmetry comes from this equation, x equals negative b over 2a. Our vertex, remember any vertex, of course, is, can we see this, x, y, every single time. So once we figure out our vertex, our axis of symmetry, we figured out the x value here, right? And then we can plug in what we know as the x value and find the y value. Okay? F of negative b over 2a is just a fancy way of saying what is the value of the function if you know what your x is on the line of symmetry. So it looks complicated, but if you think about it, it's really not. Okay. Graph the axis of symmetry and the vertex. If we're having to do this manually without our handy-dandy Desmos, we're going to graph the axis of symmetry, that's a vertical line, and our vertex, that's a point. It's either the maximum or the minimum, right? And then we're going to find and graph a couple of additional points so that we can sort of see what our graph parabola, of course, is going to look like. Okay, so number one, it says find the equation of the axis of symmetry, and so I need negative b and 2a, right? So I know in this case, a equals 1, b equals nothing, a whole lot of nothing, 0, right? No x, and then c equals 1. So if I want to find the axis of symmetry, it is at x equals, b was 0, so negative 0 over 2 times 1. So that's negative 0 doesn't matter, it's just 0, right? Over 2, which is 0. I have a vertical line at x equals 0. That is the y-axis, right? This is my y-axis. So my instructions tell me to find the equation of the axis of symmetry and find the vertex. So I know the x part of my vertex already, right? The x part is already 0. I need the y part. So I'm going to plug in if x equals 0, 0 squared is 0, 0 plus 1 is 1. The y value is 1. We're going to plot or graph the axis of symmetry, and we're going to graph the vertex. So let me see if I can find a highlighter. Hold on. All right, what you don't know, because my video was paused, is it took me a minute to find a highlighter. So now hopefully this works. Okay, I found my axis of symmetry, and I found my vertex, and so number 3 tells me graph the axis of symmetry. Well, I said it's the vertical line at x equals 0. Here's my origin, so x equals 0. This is my axis of symmetry. That highlighted yellow spot. Okay, so I know that the whole parabola is going to be the same distance to the left as it is to the right of that line of symmetry. It says graph the line of symmetry, graph the vertex. Well, my vertex we calculated out is at 0, 1. So 0, 1. This is my vertex. Now I need to figure out what my parabola is going to look like. Okay, so I'm just going to pick some x values that I'm willing to work with, and I'm going to plug them in. So let's graph. Okay, if x is negative 2 times negative 2 is positive 4. 4 plus 1 is 5. So far, so good. Okay, if x is negative 1 times negative 1 is positive 1, and positive 1 plus 1 is 2. If x is 0, y is 1. We know that already. If x is 1, what happens? 1 squared is 1, and 1 plus 1 is 2. If x is positive 2, 2 squared is 4, 4 plus 1 is 5. All right, so that seems like that's going to give me an idea of what this parabola is going to look like. I'm going to plot all these points. Negative 2, 5. Negative 1, negative 2, and then 1, 2, 3, 4, 5. Negative 1, 2. Negative 1, 1, 2. 0, 1. We already have that. That's my vertex. 1, 2, 1, 1, 2, and 2, 5. 1, 2, 1, 2, 3, 4, 5. All right, look at that. It is making a parabola for us. So I can kind of gently draw myself a parabola. I can see that parabola is opening up. Did it cross my x-axis at all? No, it did not. I don't have any x-intercepts, right? I do have a y-intercept right here, where x equals 0, y equals 1. And my domain, it looks like if I kept drawing forever, ever, I would go forever to the left, negative infinity, forever to the right, positive infinity. And remember, we use those parentheses to show that. And I'm looking at my range. What are the possible y values? Well, it looks like y has to be greater than or equal to 1. Okay, so the smallest y value I can have is 1. And I can get as high up as I want to. I get all the way to positive infinity. Okay, so that's just writing an interval notation, which is kind of easy to do and easy to see. So that's what I'm going to do for now. Okay, moving on. Oh, and wait, did it make sense? Yes, our A value was positive, so we expected to open up, right? And can I factor x squared plus 1? I cannot. X squared is a square, and 1 is a square. Those are both perfect squares, but it's not a difference of squares. So that's it. That guy's prime, yeah? Prime. How many times did I cross the x-axis? 0. I wonder. Okay, moving on. Here, I know that, I'm going to write it on this side this time. A equals 1, B equals 2, C equals negative 1. Since A is 1, I expect my parabola to open up, right? Just roughly, I know it's going to probably open up. All right. I'm going to have a y-intercept at negative 1 at y equals negative 1. Okay. Just things that we looked at previously. Now, my axis of symmetry is going to be when what my x value is when I look at negative b over 2a. So negative b, negative 2, right? Over 2a, 2 times 1. So negative 2 over 2 is just negative 1. My x value of the vertex, or my line of symmetry, is x equals negative 1. So it's a vertical line where x equals negative 1. So let's do that. Okay. X equals negative 1, vertical line right there. I kind of like my pink line better. That's not quite as thick as the yellow. Okay. So I'm going to be graphing my axis of symmetry, and then I need to plot my vertex. Well, I know that x equals negative 1. So what would f of x be when x is negative 1? Or we can also think, what would y be, right? X equals negative 1, so let's plug it in. I have negative 1 squared, yeah, plus 2 times negative 1 minus 1. It's negative, so really be careful. Definitely use parentheses so you can keep track of what you're going to end up with, okay? Negative 1 times negative 1 is positive 1. 2 times negative 1 is negative 2, and I bring down that negative 1. 1 minus 2 is negative 1 minus 1. Negative 1 minus 1 is negative 2. So my y value is negative 2. Y equals negative 2. My vertex then is the xy, where I have x is negative 1 and y is negative 2. Okay? So let's plug in my vertex at negative 1, negative 1, 2. All right? If I plug in negative 2 up here, negative 2 times negative 2 is 4, plus negative 4, 0, minus 1. If I plug in negative 2, I get negative 1 as my answer. If I plug in negative 1, I get negative 1 squared is 1. 1 minus 2 is negative 1, minus 1 is negative 2. We already did that, right? Because we know that that's our vertex. If x is 0, y is negative 1. If x is 1, 1 plus 2 is 3, minus 1 is 2. And if x is 2, 4 plus 4 is 8. 8 minus 1 is 7. Do I have all of those numbers right? Negative 1, negative 2, negative 1, 2, 7. Okay, let's plot some points. Okay, we got a whole bunch of points. Let's plot them and see what it looks like. Do I expect my parabola to open up or down? That's a positive a, so I'm expecting it to open up. We already talked about that. So I have negative 2, negative 1, 2, negative 1. I have negative 1, negative 2 already. I have 0, negative 1. I have 1, 2. And I have, here's my origin, 1, 2, 1, 2, 3, 4, 5, 6, 7. Okay, I could always, if I wanted to, even plug in like negative 5 or something if I felt like it and wanted to see what else that parabola is going to look like. You know it's going to be symmetric about that axis though. So if this is my axis, womp, 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 I have a 0.3 to the right. This is my axis, womp, 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 I have a 0.3 to the left. Okay, my parabola is opening up. My vertex is at negative 1, negative 2. My domain is going to be all real numbers in this case. I don't have any barriers on the x, so I can go from negative infinity to infinity. But I do have some barriers on my y. The very smallest y I can have is negative 2, right? So I know that all of my y's have to be negative 2 or more. right? I can't have any y value that's going to be less than negative 2. Okay, we also can say y such that y is greater than or equal to, don't forget that part, negative 2. Okay, and that's the set of numbers that could be y such that y is greater than or equal to negative 2. We can say it that way too. Okay? Okay. We're just going to get through 2 more examples and then we will be done with day 1 of notes. So much information, and you can see as we're having to plot these manually, you can see how lovely it is that we can use Desmos sometimes. Okay, so you could plug in any one of these equations into Desmos and it would instantaneously give you a parabola. All right, here I have f of x equals negative x squared plus 6x minus 5. So I know a equals negative 1, b equals 6, c equals negative 5. Okay, so it's negative 1, so I'm going to expect it to open downward, right? That's what I'm anticipating because my a value is negative. My axis of symmetry, x equals negative b over 2a, so that's going to be negative 6 over 2 times negative 1, because a is negative 1. Negative 6 over negative 2 is 3. My axis of symmetry is at x equals 3. Okay. Origin is 0, 0, 1, 2, 3. X equals 3, 1, 2, 3. Okay, my parabola is going to open down, and it's going to be symmetric about that pink line. All right, so let's figure out some numbers we're willing to, oh no, let's find our vertex first, so sorry. Okay, we know that the vertex is going to be at xy, where the x is the x part of our axis of symmetry. So we know the x is 3, right? Because we just calculated that. How do I find y? Well, y equals, or f of x equals, negative x squared plus 6x minus 5. I know that x is 3, though. So the f of 3, that's my x value, equals negative of 3 squared plus 6 times 3 minus 5. The negative of 3 squared, right? This is going to be negative 9. Remember that from a long time ago this year. We have plus 18 minus 5. Negative 9 plus 18 is 9, and 9 minus 5 is 4. So f of 3 equals 4. When x is 3, y is 4. That is my vertex. Let's plot it. 1, 2, 3, 1, 2, 3, 4. That is my vertex. And remember that I expect that to be my maximum because my parabola is going to open down. So let's find some points that we're willing to work with. Of course, we love when x is 0. When x is 0, y is negative 5. That's a point, right? 0, 1, 2, 3, 4, 5, my y-intercept. When x is 1, I have negative 1. Let's see. If x equals 1, I'm looking at the f of 1 equals negative. 1 squared is 1, plus 6 times 1 is 6, minus 5. Negative 1 plus 6 is 5, 5 minus 5 is 0. So the f of 1 is 0. When x is 1, y is 0. Well, that's exciting. 1, 0. I have a point right there. I'm expecting it to open down. I know that if I'm womp womp 2 to the left of my axis of symmetry, I am going to also have one at 2 to the right, right? This guy, here's my axis of symmetry. Womp womp womp. I'm 3 to the left. I know there's going to be one womp 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 3 to the right. Yeah? What's another number I'm willing to work with? Why don't we work with 1, 2, well, let's see, this would be negative. Let's do negative 2. What happens if x is negative 2, just for kicks? So the f of negative 2 is the negative of negative 2 squared. Negative 2 squared is positive 4, right? So it's the negative of 4 minus 12 minus 5. My negative 4 minus 12 is negative 16, minus 5 is negative 21. Oh, whoops, it's going to be, whoa, no, that's crazy. That might not have been the best point. So I'm going to try to choose different. I'm going to say, nah, I'm not even going to work with that guy. Okay? I don't have to if I don't want to. How about I choose positive 2? Let's see what we get with positive 2. Okay? So up here, I'm going to just be all over the place with my paper. F of positive 2, I'm just plugging stuff in. It's going to be negative 4 plus 12 minus 5. That one might actually fit on our graph. The f of positive 2 equals negative 4 plus 12 minus 5. So that's 8 minus 5 is 3. So I know my ordered pair would be 2, 3, right? 2, 3. Does it work? 2, 1, 2, 3. It looks like it would, right? And if I have a point 1 to the left of my pink line, I'm going to have a point 1 to the right. Okay, so you can do as many points as you're willing to do. That is roughly what our parabola is going to look like. So if I wanted to, I could plug in 3, and then I'd have negative 9 plus 18 is 9. 9 minus 5 is 4. I feel like we did that one. Oh yeah, because that was our vertex. And if I wanted to, for example, I could choose 4. Negative 16 plus 24, I think is 8. 8 minus 5 is 3. So you can do whatever points you want. Choose points that you're willing to work with. As soon as I saw that my negative 2 point wasn't going to fit on there, I scribbled that out and tried something new. Okay, my domain. I'm not inhibited by anything. I can go forever to the left and forever to the right. So I'm going to say negative infinity all the way to positive infinity. My range, it's going to be y such that y has to be less than or equal to, what was that at my vertex? It was 3, 1, 2, 3, 4, 4. That is my highest y value. Okay. In interval notation, I'm going to write that as sorry, I'm blanking. I'm going to use parentheses. Negative infinity goes all the way to 4, and I use the square bracket. So we kind of go back and forth. That one was easier to write out as y such that y is less than or equal to 4 as the range. Okay. Let's see. If I factored that, it would be negative 1 times x squared plus 6x, minus 6x. Fix my messes. Let's try that again. If I were to factor that, I would have negative 1 times x squared minus 6x plus 5, yeah? I need two numbers that multiply to give me 5, but add up to give me negative 6, right? So I know that that's going to be, let's write it as still a mess. Still a mess, I tell you. Okay, we're going to write that as the same as negative 1 times x minus 1 times x minus 5. I think perhaps I'm going to tell you to just erase that from your mind. That will come up later, and I'm just out of room, and it's just so messy. Let's pretend I didn't even try to factor that. So sorry. Just scratch that out of your mind. That will come on into our future, but let's pretend I didn't do that. All right, y equals 2x squared plus 8x. I know that in this case, a equals 2, b equals 8, and c equals what? Well, I don't see a constant. C must equal 0. All right, so my axis of symmetry is at negative b, so that's negative 8, over 2a. A is 2, so it's negative 8 over 4, or negative 2. Okay, vertical line at x equals negative 2. It's going to be right here. Vertical line at x equals negative 2. That's my axis of symmetry. Okay. My vertex, I know that the x part of my vertex is negative 2, and I need to find the y part. So I come back up here to the original equation. Y equals 2 times negative 2 squared plus 8 times negative 2. See, any place I had an x, I plugged in a negative 2, and I was careful to use parentheses. So this is going to be 2 times 4 plus minus 16. So it's going to be 8 minus 16, or negative 8. If the vertex x value is negative 2, the y value is negative 8. Okay, so my x was negative 2 and my y was negative 8. And I might as well include that on my graph, right? If x is negative 1, y equals 2 times negative 1 squared plus 8 times negative 1, right? I'm just plugging in negative 1 any place I have an x. So y equals 2 minus 8, which is negative 6. So if x is negative 1, y is negative 6. If x is 0, y is also 0. All right. If I were to plug in, if x is negative 4, 2 times 16 is 32, minus 32 is 0. So if it's negative 4, x is negative 4, y is 0. And then another one that I already calculated out, if x is -3, then I have 2 times 9 is 18. 18 minus 24 is going to give us -6. Okay, you can choose x values that you're willing to work with. They don't have to be the exact same x values as me. Here's what I'm going to do now is I'm going to plot by putting my vertex in, -2, -1, 2, 3, 4, 5, 6, 7, 8. That's my vertex. Do I expect this to open up or down? I expect it to open up because A is positive. Okay, which is good because otherwise it'd be off that grid, right? So let's do -4, 0. So -1, 2, 3, 4, -4, 0. That is one of the solutions, right? That's when the whole function equals 0. Let's do -3, -1, 2, 3, -1, 2, 3, 4, 5, 6. Okay. I have -1, -1, 2, 3, 4, 5, 6, and that makes sense because now I'm exactly 1 away on either side of that axis, right? So I know if this is 2 to the left of my axis of symmetry, I can go 1, 1. I know there's going to be a dot 2 to the right, right? So did I plot all my points? There's a point at 0, 0 right there. I just did. 1, 2, 3, 4, 5. Okay, we've got 5 things plotted. So we're going to go ahead and show that this would be our parabola. Okay, my domain, x can continue all the way to the left and all the way to the right. -infinity to +infinity, or all real numbers. Y, I'm going to say that we're going to say y such that y has to be greater than or equal to -8. Okay. All right. So I also could say in my interval notation, we can equal -8, -8, so used to infinity, and we can go all the way up to infinity with our vertical line. Okay. Find the axis of symmetry, vertex, and y-intercept of this function. So now we're not going to do this with the graph, right? Now we're just going to do this mathematically. So I know that axis of symmetry, x equals -b over 2a. Okay, so I'm going to, -b must be the negative of -6 over 2a. I can see that a is 1, right? If you need me to, I'll write a is 1, b is -6, and c is 4. Okay, so my x, my vertical line of symmetry, is going to be 6 over 2, which is 3. At x equals 3, I have a vertical line. Okay, the vertex, I know, is going to be the point at which x equals 3. I have to find y. So y equals 3 squared minus 6 times 3 plus 4. This is when x equals 3, because I'm just plugging it in. 9 minus 18 plus 4. -9 plus 4 is -5. The y value for my vertex is -5. Okay, this is my vertex. So I found my vertex. I found x equals 3 as my line of symmetry. And what does it want? My y-intercept. So just looking at it, that's my y-intercept, right? Y-intercept is at, it's where I cross the y-axis, so I know x has to equal 0. And the y-intercept is at 4 right there. So we're going to write it as 0, 4. Okay, find the axis of symmetry, the vertex, and the y-intercept here. So again, I know a equals -1, b equals 10, c equals -23, right? And so I know my vertical line is going to be at x equals -b over 2a. So that equals -10 over 2 times -1. Okay, so that's -10 over -2, which is 5. At x equals 5, I have a vertical line. So x equals 5 equals line of symmetry, or axis of symmetry. All right, now my vertex is going to be the xy ordered pair, where x is 5. I need to find my y. Okay, so if x equals 5, let's come back up here. I have negative of 5 squared plus 10 times 5 minus 23. So I have -25 plus 50 minus 23. That's 25 minus 23, which is 2. My y value is 2. That's my vertex. Okay, I've got my axis of symmetry. I've got my vertex. And the last thing it asked me to find was the y-intercept. Okay, I can see my y-intercept right there. The y-intercept then is at 0, -23. All right, so this is a whole lot. It's a big, heavy, meaty unit, and we are only just starting. And so we started out hot and heavy with a whole bunch of graphs. Okay, whole bunch of graphs so that you could look at the graphs and see where they're coming from. And then we realized that we can actually calculate out a bunch of important information just by using the equation. So thanks for watching. You likely have some homework in math space, and good luck as we continue the unit.